Welcome to the graphing module. For this module, we're going to have 3 lectures. We're going to cover function notation. What is a function? How do we evaluate a function? How do we write a function? How do we create a table of values for a function? And then we'll get into how to graph lines. So a function, the parameters that mean you can or cannot be a function. The idea is that for any given value of x, you can only have a single y value. And what that means is that if you run a vertical line through your graph, you should only hit that graph once. So if I look at this first straight line here and I move the vertical line across it, you can see that the line of the graph only hits the red line once at any given point. Whereas if I move down to the graph of the circle, the minute I get onto the circle, let's say here, for x equals 5 or thereabouts, there are 2 values of y. So this circle graph is not a function. Likewise, the graph up here is not a function because there are 2 values at x is minus 6, there are 2 values of y, and that is true in a lot of places. The graph below it is a function. Just writing that thing along. There's no point where I have 2 y values for any x value. The top right graph is a little more difficult to see, but if you get into this kind of middle part here where it doubles back on itself, you're getting multiple y values for a single x value, so not a function. And our parabola down at the bottom absolutely is a function. Now you may observe that if you spin your line and you use a horizontal line, this parabola crosses the red line twice, and that's fine. You can have 2 y values, or 2 x values, sorry, for any given y. It's just the other way around that is not acceptable to be called a function. So let's take a look at function notation. So that just kind of means we're taking y equals 5x and we're changing it into f of x equals 5x. We're replacing y usually with f of x, and that's just to kind of say that our equation is a function of x. It doesn't have to be f of x, it could be g of x, h of x, but usually we use f of x. It's the most common. If we have multiple things on the same graph or do piecewise or combinations, then yes, we will give them different variables to name them. So how do we evaluate a function? So if I see a question like the one here, given a f of x equals 3x plus 7, find f of 4. So what they want you to do is take that 4 and make x 4. So when you rewrite the equation, I guess you could write the f of 4, but the math you're going to do is 3 times 4 plus 7. So f of 4 is equal to 19. And you can do that for any value of x. You can build what we call a table of values. So before it was x and y, now it's f and x. Doesn't really matter. But you just keep replacing x with the value that you want to make this thing. So for the first one, if x is negative 1, 3 times negative 1 plus 7 equals 4. And then so on and so forth. 3 times 1 plus 7. And you'll notice those are all in a row, these 3 numbers, and then I skip to the number 7 because it doesn't really matter what you do. These values, these x and y values, will all be on a function. They will be points. So what I'm saying is for whatever this looks like, it will have a point that's, say, minus 1, x is minus 1, and y is 4. So very approximate. Let's say that's here. And it will have a point there, x is 0 and y is 7. And I've chosen a bad graph because I'm getting off really quickly. So it will do something. Every single one of these points must be on your graph. No matter how strange your function may be, you always have this table of values option for numerical x's. So when I look at the table of values on the right here, I've decided I want to test what x is at, the function is when x is -2, -1, 0, 1, and 2. And same idea, we're just going to sub those x values in for the variable in the equation. Watch out for your negatives and positives, knowing what happens when you've got those cubes and such not, and squares and how it acts. And you can just continue on filling this in. This will be 0 cubed minus 2 times 0 squared plus 4. Nice and easy. I've finished all the math, and I'm just going to transfer my values over to the table. So there's 5 points on this graph of f of x, whatever it may be. And when you have these strange, like cubics or things you might not know what they look like just by looking at the equation, you can build it with this kind of table of values. So I see I have a point at x equals -2, y is -12. So I'm going to put that way down here, obviously not to scale here. I have another point when x is -1, y is 1. When x is 0, y is 4. I'm laughing at my scale. And then it dips down and it goes back up, and it's doing this kind of crazy shape. And if I needed to know more, I could keep adding x equals 3, x equals 4, and see what happens. I imagine it'll probably end up doing something like this. So we've been saying find f of 1 or f of -7. Sometimes the things we want to find the function of are algebraic. They have variables in them themselves, and we're not going to get a y value that is a number. We're going to get an algebraic expression. So looking at number 1 here, if I want to find f of 0, same thing we've always done. And we're going to get -2/7. If I want to find f of 3x, you just have to be a little careful. You're going to take that 3x and change all the x's, substitute in 3x for the variable x. So f of 3x equals 5 times 3x minus 2 over 3 times 3x plus 7. And we're going to get 15x minus 2 over 9x plus 7. That's fine. That's the answer I'm looking for. We can make it even uglier, where we're going to have to take a binomial and replace all the x's with binomials, and that will require a fair amount of work for the simplification. So we're going to have g of 2x minus 1 is equal to 3 times a binomial expansion. So as per usual, I like to do the binomial expansion before I do the distribution, so I'm going to do that. 4x squared minus 4x using FOIL or an array or whatever method you use. Distributing the 5 and just the 1 that was hanging along. Another step to get that 3 distributed into the brackets. I'm going to combine the 5 and the 1 into 6. And then my final answer, collect your like terms, 12x squared minus 22x plus 9. Strange, but that is what we're looking for. Now we're going to head over and graph some straight lines. Lines are functions, except for vertical lines, and we'll get into that a bit later. They have a variable m, which represents the slope. This is the rate of change, rise over run. We'll talk about it a bit more. They have a y-intercept b. So wherever you cross the y-axis, that is your b. It'll always have the form 0, something. So it could be here, could be here, could be here. Those are your possible y-intercepts. If you're looking at a function for a line, you shouldn't see any exponents, like there's no x squared, x cubed. you should see one or two variables, maybe a y and an x, or just an x, or just a y. Those are all good. The nice thing about graphing a straight line, if you have 2 points, you've got the graph. Or if you have a single point and you know the slope, you can also graph the line. So let's talk a bit more about slope. We're going to start with the formula. M is the rise over the run. So the change in y, going up or down, divided by the change in x between 2 points. And this triangle here, delta, just represents change. The math is right here. y2 minus y1 over x2 minus x1. So what are these y2s and x1s? So if you have 2 points, and this really doesn't matter, you can choose one point to be number 1, another point to be number 2. You could have flipped that, the math will work out. I tend to be a little flippy-floppy. I mix up my x's and my y's, so good practice to label your points. So if I'm going to call this point 1, this is x1, this is y1, this is x2, and this is y2. And I'll do the same with my second question, so I can just bomb through them here. x1, y1, x2, y2. And then I don't really have to think about it. I just look up and grab what I need. So for question 1, the slope is going to be equal to y2, negative 1, minus y1, which is 5, divided by x2, which is 3, minus x1, negative 2. So watch your negatives here. We're going to get negative 6 divided by positive 5. Likewise, for number 2, and we'll talk about that graphically in a sec, y2 is 2, y1 is negative 4, minus 4. Careful. x2 is 3, x1 is 0. You are going to have 6 over 3, which equals 2. Or if you want to keep it kind of with a rise over a run, you can write it as 2 over 1. So what did this mean? So for number 1, and I'm not going to draw the plane, I'm just going to give it some coordinates. So let's say I started at the point 2, negative 5. I know this is on my line. And I look at my slope and it's negative 6 over 5. So if your rise, your change in y, is negative, you're going to count down from your first point. So I'm going to count down 6. 1, 2, 3, 4, 5, 6, about. And you're going to keep your run, your change in x, you're always going to do that from left to right. You're going to keep that positive at all times, because if you flip both, then you change the slope of your line. It messes it up. 1, 2, 3, 4, 5, or thereabouts. And if I connect those two, this would be my line. Going from negative 2, 5, it's going to pass to 3, negative 1, because I told you it was on there. Now looking at the second one, let's say I have a random point that is 0, negative 4, and I see that my slope is a whole number 2. So if you get a whole number for a slope, that just means the run is 1, right? A whole number is a fraction over 1. So here I look at my change in y, and I see that the numerator is 2. So that means up to, because it's positive. Up to, 1, 2. And then I see that my change in x always goes left to right over 1, up to over 1. There's my line. And that's all I need to draw it. We'll also go through 3, 2. So not quite on the plane, but valid. Lines can be crossing. They can cross in special ways when they're perpendicular, or they can never cross when they're parallel. So if you have two parallel lines, we know that they're always equidistant from each other. Whoa, not like this picture. And they never actually cross. So what will their slopes be? They'll be equal, right? If they're not the same, at some point those two lines will cross, and that means they are not parallel. So if you're given a question where they give you a slope of a different line and you need to use the same slope for a parallel line, you just take that m value right out of the question. If we are perpendicular, so let's draw a couple of parallel lines on here. These are parallel-ish. Different b values, different y-intercepts, but the same slope. Now if I draw a perpendicular line, perpendicular just means it makes a 90-degree angle, or it's square, a right angle. There we go. So for perpendicular lines, you can do the math. This symbol means perpendicular. It's a negative reciprocal. What I tell people is just flip the sign, flip the number. What that means is if you have been given a slope of 2/5 and you need to find a perpendicular slope, flip the sign. It was positive, so make it negative, and flip the number. It was 2/5. The reciprocal of 2/5 is 5/2. Couple more. If you have a slope of, let's say, negative 1/4, perpendicular slope will be positive because it was negative. It becomes positive. You flip it. It's 4/1, which is the same as 4. And if I gave you an integer 7, my perpendicular slope of 7, flip the number. 7/1 is 1/7, the reciprocal of 7, and make it the opposite sign. So we're going to get into equations of lines. There's lots of ways of writing lines. The two we're going to look at, my favorite, slope-intercept, and another one, point slope. Okay, so slope-intercept uses that y equals mx, so the slope right there, and b, the y-intercept. Okay, so you're going to get a point somewhere on this line, and then you're just going to go from there using the slope to find the graph of the line. Point slope is just a rearranging of the slope formula. So you have your x and your y, your unknowns, but you also have these x1 and y1, and that's just using a point. So slope-intercept uses a slope, and the y-intercept point slope uses a slope and a point that is not necessarily the y-intercept. So what kind of questions are fair game when I'm asking you about equations of lines? So I'll either ask you to find the equation or, derive some information from an equation, and I might ask you to graph the line as well. So here I've specified slope-intercept. So we're going to find our line in slope-intercept form. All right, so look at what information you're given. You're given a slope of -2. No work required. And a y-intercept of -3. So that means b is -3, and that represents a point on the graph. 0, -3. I know that the equation of a line is y equals mx plus b if we're in slope-intercept form. So all I do is sub in -2 for m and -3 for b. So that is the equation of a line with a slope of -2 and a y-intercept of -3. How do we graph it? Always start at b. So start at your y-intercept, so that's -3. I'm going to put it right here. And then use the slope to find a second point. You could use a table of values if you wanted to, not necessary. So looking at the slope, it tells me the slope is -2, which means -2/1. If the slope is negative, I go down 2. And I always go, if it's a whole number, that means over 1. So there's my second point right here. I'm going to try and grab my line here and move it over instead of my terrible drawing. So let's see if I can do this. I put it through that point. In my mind, this went much better. Okay, let's try and get the right slope. I promise the next one I'll draw it. I should put the end of the line there. So there's that line continuing on, or thereabouts. And you can see if I wanted to know any other values, I could either read it from the graph if it was a nice line, or I could take a table of values. So if I wanted to know what was going on when y equals 0, I could completely sub that in and figure out the x value and figure out a point, say, right here. Here's another variation of the question. This time they want the slope of a line, or the equation of a line rather, but they didn't give me much here. And they want it in slope-intercept form. So I need to find m, and I need to find the y-intercept. I have 2 points, so let's use that slope formula. y2 minus y1 over x2 minus x1. I'm going to decide what everything is, x1, y1, x2, y2. So replacing the variables with the numbers, negative 3 minus 5 over 2 minus 4 equals negative 8 over negative 2, which equals a positive 4 slope. Sweet. Okay, so I've got part of it. Now I know, and this is the important part where people kind of get lost. I know this. I still need to find my y-intercept. Well, I gave you these points. Both of these points are on the line. And that's an x and a y. So you can replace in your equation x and y with x1, y1, or x2, y2. Choose one point and stick with it. Both of them will give you the same answer. So let's say I used point 1. 5 from the point, this 5 here, equals 4, the slope, times the 4 from the point, plus b. 5 equals 16 plus b. A little bit of algebra. 5 minus 16 equals b. b equals negative 11. So the equation of my line, remember to sum it all up, is y equals 4x minus 11. Now we're going to graph it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Start at your y-intercept, negative 11. My slope tells me up 4. 1, 2, 3, 4. And over 1. There's my second point. I think maybe I'll just try and draw it. It's going to be hideous. And there is a very rough sketch of the line. Let's continue to pile on. So in this third question, I still want y equals mx plus b form. I gave you 2 lines. These are not my answer, but I'm going to take information from this line. The highlighters are not working today. And I'm going to take information from the second line. Okay, so let's reread the question. Find the equation of a line perpendicular to y equals negative 2/3 x plus 7. So perpendicular means I'm concerned about the slope. So if the slope of another line that I will be perpendicular to is negative 2 over 3, I know that my slope will be positive, flip the sign, and it will be 3 over 2, flip the fraction. Okay. Now, my line will also have the same y-intercept as y equals negative 4x minus 3. So this piece of information is what I'm taking from the second line. And now I have enough to draw the equation. 3 over 2x minus 3, y equals mx plus b. In order to graph it, I start at the y-intercept, the b value, 1, 2, 3, start right here, and then I do what it tells me to do. It's a positive, so I'm going to go up 3 for the numerator, and I'm going to go right 2 to get the second point. Rise up 3, run right 2. And then I connect the dots, and there's my line. Sometimes your line doesn't look like you want it to look. That's fine. You're just going to take this line here. It appears to be in standard form, which we're not going to deal with because it's kind of boring. But we're going to make it into y equals mx plus b. So I want to take the x and the constant and move it over to the right side of the graph. First step. Leaving the y behind. If it moves over to the right side, both of those things become negative. Step 1. Now, slope-intercept form, you cannot have a coefficient in front of the y, so I need to divide out the 5 that's attached to the y. The math for that is I'm just going to divide everything by 5. It will change the left side to plain y. The slope is negative 2 over 5. And the y-intercept is negative 2, 10 divided by 5. And now I'm ready to graph. Find your y-intercept. It's 2. deal with your slope, I need to go, it's a negative slope, so I need to go down 2, and then I need to go over 5. 1, 2, 3, 4, 5. Obviously approximate, and here we go. A straight line connecting those 2 points. Continuing over to point slope form. So my question here is find an equation of a line parallel to y equals 4x minus 7. So right away I know that my slope will be 4 if the line is going to be parallel. That passes through this point. Now I don't need to find the y-intercept there. I can use this point, but we have to just make sure we put it in the equation correctly. So point slope form, y minus y1 equals m x minus x1. And these y1 and x1s just come from the point that you were given. Okay, so y minus -3, so careful, the signs get kind of hinky in here, and then 4 on 2 for the slope, x minus 2. Y plus 3 equals 4 on 2x minus 2. I can graph from this. Instead of trying to start on the y-intercept, I'm just going to start at my point. So if I have a point that's 2, -3-ish, it goes here. And then if I want to use a slope of 4, I'm going to go up 4 over 1. Ooh, really not to scale this time. And there's my line. If I'd asked you to change it to slope-intercept form, that's easy. You're just going to kind of gather everything on the right side except for the y. So if I wanted to change my line, I'm kind of trying to do it over here so it doesn't get as confusing. Y plus 3, do the distribution, 4x minus 8, and then I'm going to move the 3 over. Y equals 4x minus 11. So these two lines are the same thing, just in different forms. Point slope is handy when you're nowhere near the y-axis, so it becomes inconvenient to try and figure something out so far away, and it won't be like easy to graph. So let's do an equation of a line through 3, -12, and -18, 17. So this time I don't have a slope, so I'm going to use the slope formula. Just labeling up, starting with y2 minus y1 over x2 minus x1. So y2 is 17, subtract -12 divided by -18, subtract 3. So I get 29 over -21, and I'm just going to change that to -29 over 21. Put the negative up top because the y kind of decides whether you're going up or down. Fine. I have enough information now. Choose one of the 2 points. It doesn't matter which one. I'm going to use this one. If you are in point slope form, the equation is and we're just going to replace anything we found or can take. So, sorry, y minus -12 for y1. We just found the slope to be this lovely fraction. And then x minus 3, and just kind of dealing with that double negative. Done. My last slide is just going to talk about horizontal and vertical lines. So horizontal lines, when you have an equation for a horizontal line, you're going to notice something. There is no x in the equations. You could have y equals 7. This second one here, you can rearrange that. And it is the same as y equals -1 over 4, or 1/4. They will always have a y-intercept because there's a horizontal line. So of course they're going to cross the y-axis. And they're going to have a slope of 0. And the reason behind that is, let's say we had 2 points on the line y equals 7. One of them could be -2, 7. The second point could be 3, 7, noticing that y value always stays the same because y is always equal to 7. And if you did the math for the slope, you would end up doing 7 minus 7 divided by 3 minus 2, and you get 0 over 5, which is 0. Okay, so horizontal lines have a slope of 0. That's important. And how do I draw them? You just find your spot. 2, 3, 4, 5, 6, 7. Here's y equals 7. Y equals 1/4, or negative 1/4 is like just very close to the x-axis, just like that. Flipping over to vertical lines, they have no y. So it's kind of a little counterintuitive, but it makes sense. So a vertical line doesn't need a y in it because all values of y will have the same x. And once again, if I rearrange this 6 minus 2x, I end up with minus 2x equals negative 6. And it tells me this line is actually got an equation that is x equals 3. So they're not going to have a y-intercept unless the equation is x equals 0, and then it just is running right up the y-axis. And they have a slope that is undefined. Don't say infinite. People like to say infinite, but the slope is not infinite. It is undefined. And the reason behind that is, let's take 2 points on the line x equals negative 3. Let's say negative 3, 6, and negative 3, 1. When you do the math there, you do 1 minus 6 for the change in y, and you do negative 3 minus negative 3, and it's going to give you negative 5 over 0. This is a situation you're not allowed to have, a fraction with 0 in the bottom. So we always say that the slope of a vertical line is undefined. And if I wanted to graph these bad Larrys, x equals negative 3, let's say it's probably something like this, except straighter. X equals 3 here. Oh my. So that's basically everything you need to know about function notation, kind of evaluating functions, and graphing straight lines. Next up, we're going to do graphing quadratics and be drawing a few parabolas.